Hi everyone, it's Miss Berry. Today in this video, we're going to be going over section 8.3, which is called Estimating Population Means when Sigma is Unknown. All right, so this is going to be very similar to what we did in section 8.1, but this time we're going to be combining what we learned in section 8.1 with what we did in section 8.2. So we're really just synthesizing those two sections and putting it all together. All right, so I'm going to go ahead and share my screen with you and we'll get started. All right. I think I am sharing with you now. Okay. Okay, so estimating population means when sigma is unknown. All right, so once again, we are creating these interval estimates for our population mean. The only difference is that this time we will not know the population standard deviation. All right, so if you remember, that's what sigma stands for. All right, so sigma is the population standard deviation. Okay, so that in these scenarios, we're not going to know sigma. Now, this is a very common scenario, and if you go on to take another stats class, you will definitely do something like this. All right, so now that we learned about students' t distribution, the students' t distribution in section 8.2, we're now going to connect that with how we constructed confidence intervals for population means. But this time, the scenario is going to be that the population standard deviation is unknown. It's a very realistic scenario. And if you do any kind of research where you have to do statistical analysis in the future, you will most likely be using the student's t distribution. So in real life, if you were constructing a confidence interval for a population mean and your population standard deviation was unknown, you would start by checking the following three criteria. You would want to make sure that a simple random sample is being used. You would want to make sure that the population standard deviation is indeed unknown. So that might look like, looking at prior research, making sure that no one's already determined what the population standard deviation is. And then lastly, you want to make sure that you have a sufficiently large sample size, which we define as being at least 30, so 30 or more, or you need to know that the population comes from a distribution that is known to be approximately normal. All right, so again, that would be, you could determine that by looking at prior research in the field. All right, so in our scenarios, we are just going to be assuming that those criteria are being met. But of course, in real life, if you were actually conducting this research, then you would have to check that yourself. All right, so number one says, a researcher records the price of 130 randomly selected refrigerators from Home Depot, a sample mean of $3,169.71, and a sample standard deviation of $1,699.11 was subsequently computed. Construct a 90% confidence interval for the mean cost of a new refrigerator. Okay. All right, so let's take a second, write down the important stuff. I'm going to highlight it here. So here's our sample size, 130. That is definitely sufficiently large, right? So we define sufficiently large to be 30 or more. There's our sample mean. And then our sample standard deviation. All right, so we're going to need those three things. And of course, we're going to need to know the confidence level. All right, so I'll just write all this stuff down here. Sample size. Sample size was 130. Sample mean X bar is 3169.71. Sample standard deviation, which we call S, All right, so that's the symbol for the sample standard deviation was 1699 and 11 cents. And then our confidence level is 90%. As a decimal, that would be 0.90. All right, so let's get our calculator fired up. If you don't have your calculator, you might want to pause the video and grab it. All right, so we're going to be going to the same menu that we went to in section 8.1. If you remember how we got there, we pressed the Stat button, and then we went over here to Test. Right, and if you remember from section 8.1, we were doing Z intervals. Since we do not know the population standard deviation here, as we saw in the problem that they reported the sample standard deviation. So if you do not know the population standard deviation, you have to do a T interval. All right, so we're going to scroll down to T interval, hit enter. And once again, just like on Z interval, if you had to manually type the data in, then you're going to put data. So if you had to manually type the data into L1, then you would select data. We were just given the statistics, so we're going to choose stats. And in here, we're just going to type in our numbers. So what was it? 31, 69, 71. I'll have to double check that. 31, 69, 71. Okay. And then for our sample standard deviation, 1699 and 11 cents. 1699 and 11 cents. Our sample size was 130 and our confidence level was 0.90. Go down to calculate and hit enter. And there's our confidence interval up here at the top, 29, 22 and 80 cents, and then 34.16 and 60 cents. Okay, all right, so let's jump back over to our problem and we'll write our confidence interval. All right, I'm going to switch to a different color there. All right, so here's our confidence interval, $2,922.80. Just doing two decimal places since we're talking about money. And then $33,416.60. All right, so I'm going to write a sentence interpreting this confidence interval. You're not required to on the homework, but once again, just like we talked about in section 8.1, the way that you go about, so that the methodology of, how do you go into the program and construct these confidence intervals, that's going to change based on what statistical program you're using, whether it's the calculator or Excel or SPSS or SAS or R, but the interpretation is going to remain the same. So it's important that you understand the interpretation. So we're going to say we are 90% confident that the true mean, and again, we're just using that same template from section 8.1, that same sentence template, that the true mean cost of a new refrigerator, and you could specify that this is specifically at Home Depot. So we're 90% confident that the true mean cost of a new refrigerator is between, I put my units there, it's dollars, so $2,922.80 and $3,416.60. Okay, and remember we said that what this is really saying is that if we constructed 100, say we constructed 100 confidence intervals, we are confident that out of that 100 confidence intervals that we constructed, 90 of them would contain the true population mean. Right, so that is the interpretation of a confidence interval. All right. A random sample of 10 rye fields has a mean yield of 45.4 bushels per acre and a standard deviation of 2.93 bushels per acre. Determine the 80% confidence interval for the true mean yield. Assume that the population is approximately normal. So we have this small sample size, so the question had to tell us that this variable comes from a approximately normal distribution. And it's asking us two things here. It's asking for the critical value and it's asking for the confidence interval. So if you remember how to find the critical value, we're going to need to pull up our little table. Let's see if I can find it real quick. There we go. All right, there's our critical T table. All right, so we need to grab our information. All right, so our sample size was 10, so that means our degrees of freedom is what? Do y'all remember from the last section? Degrees of freedom, degrees of freedom is equal to the sample size minus 1. So in our case, our degrees of freedom is going to be 9. And we're looking at a 80% confidence interval. So that means that we've got 80% in the middle, so 0.80. So how much is left over in the tails? 0.20, right? So 0.20 in 2 tails. All right, so let's use that information to read our critical value off of the table. All right, let me zoom in a little bit. All right, so here's our, try to highlight it. Doesn't want to let me. I'll just draw on it. Okay. So we're looking, oh, I know what the problem is. Okay. So we're looking right here in the degrees of freedom is 9. And we're looking in the area in 2 tails is 0.2. So it's this first column, 9 degrees of freedom. Our critical values are 1.383. 1.383. And remember, we actually have 2 critical values since we're working on a confidence interval. We've got a negative t and a positive t. So we said that our critical value would be 1.383. And we know that we also have another critical value, which is negative 1.383. All right, now what are these critical values used for? Well, your calculator is using them behind the scenes to construct the confidence interval. All right, so you're not seeing that, but what's happening in your calculator is that they have those built-in functions that are utilizing these confidence levels, or excuse me, that are utilizing these critical values to come up with something called the standard error, and that's what allows us to construct the confidence interval. Okay, you can find these find these critical values in the calculator. So let me show you how to do that. Let's clear this out. To find the critical value in the calculator, if you have an older version of this calculator, you are not going to see this option, which is why I've shown you how to do this without using the calculator. All right, so you're going to go to second vars, and then option 4 says inverse t. All right, so if you're not seeing that, that's okay. So if you're not seeing that, that is totally fine. Now, it only has 2 options here. It says area and degrees of freedom. Area means area to the left. So in our little picture, let me see if I can get it to pull up. There we go. In our little picture, we said that this is 80% in the middle. That means there's 20% or 0.20 in the tails, and that has to be split up equally in both tails. So that tells us that we're going to have, sorry, I'm trying to find my mouse. Lost it. There we go. So that tells us that we're going to have 0.10 in the left tail and 0.10 in the right tail. All right, so our area to the left of our critical value The area to the left of our critical value is going to be 0.10. All right, so 0.10. And then our degrees of freedom, we already said was 9. And then we'll hit paste. It's going to paste it onto the home screen. And there you can see we got the same value from our table. I personally think it's easier to use the table. That was a lot of work to find that inverse t value or to find that critical t value. But if you would like to use your calculator to do it, you are more than welcome to do it that way. All right, so now we have to construct the confidence interval. All right, so let's grab our calculator again. I'm going to take a second and write down the values so that I don't forget. Our sample size is 10. Our sample mean was 45.4. Our sample standard deviation was 2.93. And our confidence level is 0.80. Right, so I'll write that down for y'all as well. All right, so sample size is 10. X bar, the sample mean is 45.4. S is 2.93. And then our confidence level is 0.80. All right, let's clear this out. We'll go to second, or excuse me, not second. We're going to just go to the stat button. So we're going to the stat button. We're going over to test. We're going way down here to T interval, option number 8. And then we're going to type in our information, 45.4 for our sample mean. Sample standard deviation is 2.93. Sample size was only 10. Confidence level was 0.80. Then we're going to go to calculate and hit enter. And there's our confidence interval. I forget what we were supposed to round to. They said 1 decimal place. All right, so 44.1 to 46.7. 44.1 to 46.7. All right. And again, if we were interpreting this, we would say something like, we are 80% confident that the true mean, let's look in the problem for what words they use, the true mean yield. All right, so that's what we'll say, that the true mean yield for fields of rye is between 44.1 bushels per acre and 46.7 bushels per acre. Right, so we're 80% confident. So that means if we were to generate 100 confidence intervals, we would estimate that 80 of those confidence intervals would contain the true mean, the true population mean. Okay. Next, we have a problem that has a little data set. So I'm going to show you how we would calculate or construct a confidence interval. If we are given a data set, it says Blueprint LSAT is a program designed to help students improve their score on the LSAT exam. So that's an exam to get into law school. A mock exam is given at the beginning and the end of the program to determine its effectiveness. The following data represent the net change in 5 student scores on the exam after completing the course. So a -5 would mean that the student score went down 5 points after taking the course. A +19 would mean that the student score went up 19 points. So negative is bad, positive is good. A 0 here would mean they scored the same thing on the pretest that they scored on the post-test. Right, so this is a common way that people measure effectiveness of assessments or of programs. So they do like a pretest, post-test, and then they look at the change in the scores. All right, so it says using this data, we're going to answer the questions below. First, we're going to calculate the sample mean for the data set. Okay, so we know that the first thing we have to do is type in our data into our calculator. So I'm just writing down our values. All right, let's grab our calculator, clear this out. Now we have a data set, so we need to go into L1. We need to go to edit and clear everything out. I still got my stuff from 8.1 in there. All right, so now I'm going to type in my numbers. Make sure you do a -5 and not the minus. The calculator doesn't like that when you do a negative, or when you do a minus instead of a negative. All right, then 19, 4, 0, and 1. You do want to make sure and include the 0 because that's important to know that the student's score did not change, right? So 0 here does not represent nothing. It represents that there was no change in the score. All right, so once you've got your data typed in, we're just going to go back to stat and go over to test. You could go to calc and run your one variable stats. That would be fine. You just don't have to, because if we go to test, it's going to tell us the sample mean, right? So we're going to go to T interval. This time we want to tell the calculator that we've typed a data set in. So we go to data and hit enter. And then you need to make sure that it says L1. So you've got it in the right list. You've got it looking in the right place. Frequency should be 1. And then what was our confidence level here? I forget. Oh, it didn't tell us. That was on the next problem. So our confidence level was 85%. That's on part D. Whoops, went too far. 85%, so 0.85. 0.85. All right, and then we're going to hit calculate, and there's our confidence interval. And you can see that it also reported my sample mean. All right, so it went ahead and told me my sample mean, it told me my standard deviation, my sample standard deviation, and it told me the sample size. All right, so I'm going to grab that sample mean, so 3.8. That was my first question. To calculate the sample mean, round to 1 decimal place, we would say X bar is 3.8. Now let's think about what this means in terms of this particular data set. Okay, so this would mean if you were advertising this Blueprint LSAT program, then you would say, on average, students that complete this course or complete this program improve their score by 3.8 points. Right, so that's good, right? That's a good advertisement that you could create, that students on average, after they complete this course, their scores are going up almost 4 points. And that would have been even higher if we hadn't had this person that went down 5 points. All right, so sample standard deviation to 1 decimal place. Sample standard deviation we said was 9.1. All right, so 9.1, that's a pretty large standard deviation, right? Like typically we see that our standard deviation, I don't know what happened there. Typically we see that our standard deviation is smaller than our mean, but this one was larger. All right, so that's not so good. If we were trying to advertise for this program, we would probably not want to advertise that. So there's a lot of variation in our data since we have such a large standard deviation. All right, and then it says find the critical value and then construct the confidence interval. We'll go ahead and write the confidence interval, and then we'll grab our critical T table. All right, so let's grab our confidence interval. It was to 1 decimal place. Yes. All right, so our confidence interval to 1 decimal place would be -3.4 to 11.0. -3.4 -3.4 to 11.0. All right, so if we were to write a sentence interpreting this, we would say something like, we are 85% confident that the true mean, and then we'll go back and look at the wording in the problem, that the true mean, let's see what they said in the problem. Or actually, it was right there. I totally missed that. The true mean net change in a student score after completing the program. So that's kind of long. Let's see if we can shorten that. That the true mean net change in score after completing the program is between, remember these are points, so we would say between negative 3.4 points and 11.0 points. You got a really wide range here. And again, if you were trying to use this for like advertisement purposes, this might not be a great advertisement because you're saying, sure, there's a possibility that you can increase your score by 11 points, but there's also a possibility that you might decrease your score by 3.4 points. So again, this would not be a particularly good sentence to use for advertisement purposes. All right, now let's go grab our critical value. Again, you could use that inverse T function in the calculator, and I'll show you how to do that. But I think it's actually easier just to use the table. All right, so just recall our sample size was 5. So that means our degrees of freedom is what? All right, so our degrees of freedom, sample size minus 1. So that's 5 minus 1, which is 4. And then our, let's think about the area and the tails. All right, so we got an 85% confidence interval, so that means 0.85 is in the middle. That means that we've got 0.15 in the tails. 1 minus 0.85. Right, so we would do 1 minus 0.85. So that's what's in the tails. All right, so let's grab our table. We're looking at the area and 2 tails. We actually don't even have this option on our table, so I guess we'll have to do this in the calculator. All right, so as you can see, we have 0.2, 0.1, 0.05, 0.02, 0.01. So we don't even have the right information in our table to use the critical T table. That's kind of annoying. So we're going to have to use the calculator to do this one. Now, you can totally, if you were trying to do the homework and you were trying to look for this critical value, you can just Google like critical T table 85% or something like that, and you could probably find it. But let's figure out how much is in each tail. So we've got 0.15, and that's got to be split up equally between our 2 tails. So we take our 0.15 and you divide that by 2 to figure out how much is in each tail. So that's 0.075 in each tail. Right, so let's just write that down. 0.075 in this tail, 0.075 in that tail. Okay, so that's the area to the left of our critical T value right here. Remember, we've got 2. We got 1 on that side, a negative 1, because in the T distribution, 0's in the middle. All right, so let's grab our calculator, and we'll have to do the inverse T option. All right, so clear that all out. We go to second vars, go down to inverse T. Area is 0.075. Degrees of freedom was 4. And then we hit paste. Then hit enter again to run it. There's our critical T value. So they said 3 decimal places, so that's negative 1.778. Negative 1.778. All right, so again, we've got 2. Positive T would be 1.778, and the negative T would be negative 1.778. So we actually just found this one in the calculator, but it's going to be symmetric. We know that the T distribution is symmetric, so we can just flip it over and get the positive version of that for our other critical T value. All right, and our last problem is about grizzly bears. It says wildlife conservationists studying grizzly bears in the United States found that the mean weight of 27 adult males was 623 pounds. All right, so I'm just going to highlight some of this important stuff as we go. All right, 27 adult males, sample mean was 623. Sample standard deviation is 88 pounds. Construct a 90% confidence interval for the mean weight of all adult grizzly bears in the United States. Assume that the weights of all adult male grizzly bears in the United States are normally distributed. Why do they tell us that? Because we had a sample size that was less than 30. All right, so we had a sample size that was less than 30. So they had to tell us that the population came from a normal distribution, or that the variable came from a normal distribution. All right, and the directions say to round to the nearest whole number, so that's different. We haven't been doing that. And we're not doing that, like, ignore your rounding rules stuff like we did for minimum sample size. This is just saying use your normal rounding rules, but round your answers to the nearest whole number. All right, so let's write down all of the important information. Sample size is 27. Sample mean is 623. Sample standard deviation is 88. And our confidence level is 0.90. All right, so grab your calculator, clear this out. Now we're constructing a confidence interval, so we go to stat, then over to test, go down to t-interval. This time we are just typing in the statistics, so we go to stats and hit enter. Our average weight was 623, 88 for our standard deviation, 23 for our sample size, and then was it 0.95? Double check. 0.90, sorry. So 623, 88, 27. Oh my gosh, y'all. I need to get it together. 27.90. I'm just going to double check that one more time. Yes, 27 adult males, 623, 88.9. Okay, cool. All right, hit calculate. And there's our confidence interval. We're supposed to round to the nearest whole number, or excuse me, y'all, hold on. Let me get it together. We're supposed to round, use our normal rounding rules to round to the nearest whole number. So that's 594. And then this one's going to get rounded up because it's a 0.8. So 594 to 652. 594 to 652. 594 to 652. All right, let's write a sentence and then we'll be done. We are 90% confident. I don't know what happened there. Let me just start that over. We are 90% confident that the true mean, and let's see how they worded the variable, the weight of adult male grizzly bears in the U.S., that the true mean weight of adult male grizzlies in the U.S. is between, then we put our values, in context, that would be 594 pounds and 652 pounds. So sorry about my sloppy handwriting. I swear it's better in real life. It's just this writing pad. It's hard to write neat on it. Okay, so before I sign off on the video, I just want to make sure that it's clear. I'm going to try to do this off to the side. If you're finding a critical value, then you're going to go to second bars. If you're constructing a confidence interval, then you go to stat and you go over to test. All right, so that might be something that you want to add to your formula sheet. Okay, let me switch back over to my camera. Okay, all right, that's everything for this video. If you have any questions, I hope you'll let me know, and I'll see you guys next time.